Hey y'all, welcome to Miss Clark's chemistry class. I have promised you more tutorials on dimensional analysis, and that's exactly what I have. These are a little bit more complex, so if you're needing some beginner problems, go back to that first tutorial video. All right, go get your notes, get a calculator, just notes and calculator. Let's get started. Now, if you're in my class, I just had this question on a test, and that's the reason why I threw it in here, was because several people missed this question, and so I thought this would be a good one to work for everybody. Let's look at the question. It says, Betty has been working for a fast food restaurant for the past 35 years wrapping burgers. Each hour, she wraps 184 hamburgers. She works for 8 hours a day. She works 5 days a week. She gets paid every 2 weeks with a salary of $840.34. How many hamburgers will she have to wrap to make $1 million? Okay, now, I think this type of questioning is a little bit more complex because there's many numbers in the problem. Most of the time we're used to just going to look at our problem, getting our given, making some conversion factors, going about our business. But when there's so many numbers in our question, sometimes we don't even know where to start, even if we're feeling good about our ability to do dimensional analysis. Now, my first tip is to always look in the questioning sentence. How many hamburgers will she have to wrap to make $1 million? Most of the time, you're going to find the given by rereading the question. And that is true for this problem as well. Our given is $1 million because we want to know how many burgers will she have to wrap to make $1 million. It's right there in our question. So we're going to start with $1 million. I'm going to put my dollar sign. I'm going to start my problem. Remember, write your given. Make your cross. Bring down your unit. Well, in this instance, $1 million unit is dollars. Okay. Again, you are not allowed to be confused. You are not allowed to ask questions. You are not allowed to not know what to do until you write your given, write your cross, bring your given unit down. Now, let me backtrack on that just a tiniest bit because like I said, one reason why this problem is a little tougher is it's hard to figure out which one is our given. So once you figure it out, then you can't be confused until you've got your given, cross, and unit. Okay, so now we know we're going to have to start adding conversion factors. Let's look back in this problem because this problem gave us a lot of conversion factors. So let's look at some numbers. We see that she wraps 184 burgers in an hour. So we could say 1 hour equals 184 hamburgers. I'm going to say HB for hamburgers. Okay, she works 8 hours a day. So 1 day equals 8 hours. Let's see what else. She works 5 days a week. 1 week, 5 days. And she gets paid every 2 weeks. Hey, y'all, 2 weeks. There was several people's problems that I noticed, and I was like, how did y'all get this wrong? You've got the problem worked out perfectly. Except for then when I looked closer, you only had 1 week was equaling $840, and it's 2 weeks is equaling to $840.34. Okay, those are all of our conversion factors that we're getting from the problem. And we know we've got to start with money. There's only one conversion factor with money, so that is where we're going to start. I'm going to put our $840 on bottom because it's got to go with our dollar sign. And we're saying that that is equal to 2 weeks. Okay, so our dollars are going to cancel out. And we're going to bring weeks down because we're needing another conversion factor. Remember, as you're adding another conversion factor, bring this unit down first. So when you get your conversion factor, you will be able to orient it in the correct way. Okay, so we've already used this conversion factor. We're not going to use it again, so I'm going to cross it out. Let me look at my conversion factors and find something with weeks in it. I've got hours, hamburgers, days, hours. There we go, 1 week. 1 week equals 5 days. Weeks cancel. I don't need that anymore. Oh, and look, here's a conversion factor with days. 1 day, but before I put that conversion factor, I've got to bring my units down. So 1 day equals 8 hours. Days cancel. I don't need this one anymore. I need another conversion factor because we're not done until we know how many hamburgers. Right now we're at hours, not hamburgers. So we're going to bring hours down. Look at that last conversion factor, 1 hour, 184 hamburgers. I'm wanting to know how many hamburgers. Here I am at hamburgers. Let me cancel out my hours. I am ready to put this in the calculator. Do not let putting this in the calculator be the thing that is annoying you, frustrating you, confusing you. You figure out the best way for you to put it in the calculator, and you do it that way, and you do it however you do it, even if I do something different, okay? Now, when I'm putting this in the calculator, I like to move from left to right, and I don't like to skip anything. So I'm going to start by putting this number into the calculator. So I'm going to type in 1 million. So after I put a million, I'm going to look. 2 is beside that on top. So I'm going to multiply times 2. My next number is on bottom. So I'm going to divide. Divide 840.34. I go to my next conversion factor. The number is on top, so I'm multiplying times 5. Top again times 8. Top again times 184 equals. How many burgers does she have to wrap to make $100 million? Now this is what my calculator is telling me. I've got 175,167,19.42. So I put my commas in. She would have to wrap 17,516,719.42. Now, sig figs in this problem, 1 million, that was one sig fig. I don't know if you would look at these. I don't know if I would really do sig figs for this problem. So I am just going to throw hamburgers after this, call it my answer. Let's do another one. The price of lead is $50 per kilogram. 1 kilogram equals 1,000 grams. 1 mole of lead has a mass of 207.00 grams. How many moles of lead can you buy with $321? So again, we're going to start with the number that's a part of the question. That's our given. Our given is this money. We're going to start with $321. I'm going to write my cross, and I'm going to bring my unit down. Now let's start thinking about conversion factors. Now, the price of lead is $50 per kilogram. Now, we've learned that we can make that into a conversion factor. $50 over kilograms, that looks like a conversion factor. We also have 1 kilogram is equal to 1,000 grams. We also have 1 mole. Now this is a chemistry unit. 1 mole is equal to the mass, 207.00 grams. Who cares that we don't know what a mole is yet? Because the conversion factor can be made, so it doesn't really matter. But we will learn more about moles as chemistry goes on. So here's our 2 conversion factors. We're noticing that we want money first. So let's do this one. But remember, 50 goes with our dollar sign. So I'm going to put 50 down here and 1 kilogram up top because I flipped my conversion factor to keep my units diagonal. Now I am looking for how many moles. Right now we have kilograms on top. That tells us to keep going. So I need another conversion factor. So whatever's on top comes on bottom. Now that I have that ready, I'm going to look at my other conversion factor. I've already used this one. So it must be this one. I've got moles and grams. The problem is I have kilograms. But remember, 1 kilogram equals 1,000 grams. So 1 kilogram equals 1,000 grams. Kilograms cancel out. I've got grams on top, but we're not asking about grams. We're asking about moles, so we're not done. I got another conversion factor. Before I think about that conversion factor, I'm going to put my unit on bottom, keep that diagonal. And then here's my last conversion factor. 207 goes with grams. And 1 mole goes on top. Mole is on top. I'm looking for moles. I must have this problem set up correctly. All my units cancel out. Let's put this in the calculator. I've got 321. My very next number is on bottom, so I'm going to divide. Divide 50. My next number is on top, so I'm going to multiply by 1,000. And my last number is on bottom, so I'm going to divide again. 207.00 equals many moles? We've got oh gosh, that's 5 sig figs. 5 sig figs. So we need 5 sig figs. 31.014, and that would be moles. I've got another problem. Let's try some more. How many 50-feet cars are in a long freight train traveling 40 miles per hour if it takes the entire train 55 seconds to pass a crossing? Again, this is a problem from my class. And so if you're in my class, I might have already worked at this for you, but it's a really good problem, and I wanted to go ahead and make it into a video. So we've got how many 50-feet cars are in a long freight train. So remember, let's go to our questioning. You know, this is all just one big question. How many cars, if we left out this 50 feet, it says how many cars are in a long freight train traveling 40 miles per hour if it takes the entire train 55 seconds to pass? I'm going to start with 55 seconds as my given. So I'm going to write my given, set my cross up, bring seconds down. Now, if we look at the rest of this, we can make conversion factors. 50 feet, it says that's what 1 car equals. How many 50-feet cars? 1 car is 50 feet. Train traveling 40 miles per hour. 40 miles per hour. Okay, we're ready. Those are our 2 conversion factors. Now, I am noticing that I'm starting with time, and the only conversion factor I have in time is hours. So before I can use this conversion factor, I've got to get seconds to hours. Now, seconds, normally you would go through minutes. You could go straight to hours if you want to, but I'm not going to. So we've got seconds and minutes. We've got 1 minute equals 60 seconds. Seconds cancels out. Now, I didn't create that conversion factor because I feel like most of us already know that 1 minute equals 60 seconds. Whatever's on top comes on bottom. I'm at minutes. I need hours, so I'm going to put hour on top. And I know that 1 hour is 60 minutes. Cancel minutes. I'm left with hours. Okay, now I can use this conversion factor. If I bring hour on bottom, I could flip this conversion factor and put mile on top. So 40 miles per 1 hour. Hours cancel out. I get it in miles. I've used this. My next conversion factor, 50 feet equals 1 car. Okay, well, I'm at miles. I need feet. Those are both distance units. And that conversion's not here, so let me just tell you what that is. 5,280 feet equals 1 mile. So since mile is on top, I'm going to bring mile on bottom. I'm going to put feet on top. 1 mile equals 5,280 feet. I'm not looking for feet. I'm looking for how many cars. But that gets us to feet, and that's what we needed. So I'm going to bring feet on bottom. 50 goes with feet. 1 car would go on top. Feet cancel. I'm left with cars. How many cars? I'm ready to put this in the calculator. Let's put this in slowly. I'm going to start with 55, so that's what I type in first. 55. My very next number is on bottom, so I'm going to divide. Divide 60. My next number is also on bottom, so I'm going to divide 60 again. I hope you're doing this with me. Grab your calculator. Put these numbers in with me. Next number's on top, times 40. Next number's on top, times 5,280. Last number's on bottom, so divide 50 equals. And I am getting 64.5 train cars. Now, we could say 64.5, and that's going to give us 3 sig figs. 3 sig figs, 3 sig figs, 3 sig figs. But have you ever seen a train on the tracks with a half a car? So normally if you're talking about physical things that you would normally not see halves of, and we know that the entire train passes by because it tells us the entire train passes by, we could go ahead and round that to 65 cars. Okay, here is my last example. The density of a diamond is 3.51 grams per milliliter. 1 carat equals 0.200 grams. How many milliliters are in a 2-carat diamond? Okay, so again, go to your question. How many milliliters are in a 2-carat diamond? 2 carat, that's our given. So I'm going to put my given, set up my cross, bring down my unit. I just went ahead and wrote carat out. Now we've got our conversion factors. We've got 1 carat equals 2 grams, and we can use this density. We can say that this is 3.51 grams per 1 milliliter. We're going to use both of these. First, we need one with carats in it. So of course, this first one is going to be the best one. 1 carat equals 0.200 grams. Carats cancel out. I'm looking for milliliters. We're left with grams. That tells me to keep going. Before I keep going, I'm going to bring my unit down to keep everything diagonal. I have used this conversion factor, and so I must be just needing this one. 3.51 grams, 3.51 grams per 1 milliliter. Grams cancels out. Milliliters on top. Yay, I was looking for milliliters. I'm done. Put this in the calculator. I'm starting with my given, 2.00. The very next number I'm going to put in is this number, and it's on top, so I'm going to multiply, times 0.200. The very next number is on bottom, so I'm going to divide. 3.51 equals, and I am getting with my given had my given had 3 sig figs, so I'm going to give 3 sig figs in my answer, 0.1139, so I'm going to round that to 4, and that would be milliliters. Okay, guys, I really hope that helped with dimensional analysis. It takes practice doing it over and over and over again. Keep your units diagonal and don't be afraid to ask for help. Okay, well, I hope that helps. Until next time, bye, y'all.